Lesson: Predictive Analytics for Demand Forecasting. Predictive analytics for demand forecasting is a cornerstone of modern supply chain management, enabling businesses to anticipate customer needs and efficiently allocate resources. By leveraging historical data, statistical algorithms, and machine learning techniques, predictive analytics provides actionable insights that drive decision-making processes. It is crucial for supply chain analysts to master these tools and frameworks to ensure their organizations remain competitive in today's dynamic market. One of the primary tools used in predictive analytics is time series analysis, which involves examining data points collected or recorded at specific time intervals. This method helps identify patterns, trends, and seasonal variations in demand, allowing businesses to anticipate future customer needs. For instance, retailers often experience increased sales during holiday seasons. By analyzing past sales data during similar periods, businesses can forecast demand accurately and adjust their inventory levels accordingly. Another significant tool is regression analysis, which helps determine the relationships between various factors and demand levels. For example, a company might use regression analysis to understand how advertising spend, economic conditions, and competitor activities impact product demand. By identifying these relationships, businesses can make informed decisions about pricing, promotion, and production strategies. Machine learning algorithms, such as random forests, support vector machines, and neural networks have become increasingly popular in demand forecasting due to their ability to handle large and complex datasets. These algorithms can automatically detect patterns and correlations that might be missed by traditional statistical methods. For instance, a major e-commerce company used machine learning to analyze customer browsing behavior, purchase history, and social media activity. This enabled them to predict demand for specific products with high accuracy, leading to improved inventory management and increased sales. In addition to these tools, frameworks such as the CRISP-DM provide a structured approach to implementing predictive analytics projects. CRISP-DM outlines 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. By following this framework, supply chain analysts can systematically address the challenges of demand forecasting, ensuring that their predictions are both accurate and actionable. A practical application of predictive analytics in demand forecasting can be seen in the case of a global beverage company. Facing fluctuating demand patterns, the company integrated predictive analytics into its supply chain operations. By analyzing historical sales data, weather patterns, and social media sentiment, they developed a predictive model that accurately forecasted demand across different regions. This enabled them to optimize their distribution network, reduce stockouts, and increase customer satisfaction. The use of predictive analytics in demand forecasting also extends to the manufacturing sector. A leading automotive manufacturer employed predictive analytics to optimize its production schedule. By analyzing historical production data, supplier lead times, and market demand, they were able to predict demand for various car models with high precision. This allowed them to adjust production levels proactively, minimizing excess inventory and reducing costs. While predictive analytics offers significant benefits, it also presents several challenges that must be addressed to achieve optimal results. Data quality is a critical factor, as inaccurate or incomplete data can lead to misleading forecasts. Organizations must invest in robust data collection and management systems to ensure the integrity of their data. Additionally, the complexity of predictive models can be a barrier to implementation. Supply chain analysts must have a strong understanding of statistical methods and machine learning techniques to effectively interpret and apply these models. Moreover, the integration of predictive analytics into existing business processes requires careful planning and change management. Organizations must foster a data-driven culture and ensure that their staff is adequately trained to leverage predictive analytics tools effectively. This includes providing ongoing education and support to help employees stay up to date with the latest advancements in the field. In conclusion, Predictive analytics for demand forecasting is an invaluable asset for supply chain analysts seeking to enhance their organization's efficiency and competitiveness. By leveraging time series analysis, regression analysis, machine learning algorithms, and structured frameworks like CRISP-DM, professionals can gain actionable insights that drive strategic decision-making. Real-world examples from various industries demonstrate the effectiveness of these tools, highlighting the potential for improved inventory management, optimized production schedules, and increased customer satisfaction. However, to fully realize the benefits of predictive analytics, organizations must address challenges related to data quality, model complexity, and integration into existing processes. By doing so, they can position themselves at the forefront of the rapidly evolving supply chain landscape.